We're going to talk about how you can identify the types of chemical bonds. Now, we've talked about 3 types of chemical bonds. Remember? Can you list them off for me? That's right! It's ionic, covalent, and metallic bonds. Although we're really never going to talk about metallic bonds again. So, the only thing you need to know about metallic bonds was said in the first video. So, we're left with ionic and covalent bonds. Well, I kind of lied in my first video. I apologize, but sometimes in chemistry, lying is important. Because sometimes you have to lie to get to the truth. But before I talk about my lie, I want to just kind of jump and talk about the 2 things I did say in my last video. I talked about pure ionic bonds. And a pure ionic bond is when the electrons are totally and completely stolen from one atom to the other. Let's think about this. On the periodic table, which ones want to steal electrons? That's right. Anything on the far right side really wants to steal electrons. Except, of course, for the noble gases. We don't really talk about those guys because they don't really react with anything else. So why should we talk about them? The nonmetals are the ones that steal electrons, remember, and the metals are usually the ones that kind of give them up, okay? So we talked about pure ionic, and pure covalent was kind of the opposite. Instead of electrons being stolen, they're actually evenly shared. So what I want to talk about is, why does that happen? Why do ionic bonds get their electrons stolen, whereas covalent bonds share their electrons? What's the real reasoning behind that? Well, the first thing we need to look at are what we call nonpolar covalent bonds. Now, let's review what the term polar means. Nonpolar means no charge. Let's think about how atoms even get to be charged. Atoms will be charged if they lose completely or they gain completely an electron, right? They gain electrons, they get negatively charged. If they lose electrons, they get positively charged. What does no charge mean? It means that their number of electrons haven't changed, right? They don't really gain anymore and they don't lose anymore. They kind of have the same amount. Well, we know that chlorine, it's always just one short of having a full set, right? Well, this chlorine molecule also is one short of having a full set. So instead of stealing each other's electrons, what they do is they kind of share the electron so that they both get their full 8. But do you see how neither of them actually takes away the electron? Because no electron's actually taken away or added, they don't have a charge. So nonpolar means there's no charge. It means that both atoms are still neutral, okay? They share equally the electrons between both atoms, so there's no charge on the atoms because there's no loss or gain of electrons, okay? I talk about the fact that they're sharing electrons. What's actually happening is this. There's 2 atoms of chlorine. They both want the electron the exact same amount. So what's really happening is they're not really sharing their electrons. They're actually pulling on the electrons, but with equal strength, so neither of them gets it. So here's the 2 electrons in the middle. And if both of them pull with equal strength, do either of them really gain any electrons? No, it's just kind of like equally shared between the 2. Okay? So that's nonpolar. It's when 2 atoms want the same electrons, the exact same amount, so that it's perfectly evenly shared between both of them. Okay? Now the other type of bond I'm going to briefly talk about is polar covalent bond. Now a polar covalent bond means that both of the elements, they're both still nonmetals, because remember covalent has to be a bond between 2 nonmetals. So hydrogen is a nonmetal and chlorine is a nonmetal. However, chlorine wants the electron that hydrogen has a little bit more than hydrogen actually wants chlorine's electron. Because remember, if hydrogen has 1 valence electron, it wants 2 electrons to be filled. And chlorine has 7 valence electrons, so it wants 1 more. It wants 8 total to be filled, right? So they both want an electron from the other person, but chlorine actually can pull on the electron a little bit harder. And so if it pulls on the electron a little bit stronger or more than hydrogen does, guess what happens? Instead of them being evenly charged, this is kind of what's happening. Here's chlorine. Okay, it can pull a little bit stronger on hydrogen's electron than hydrogen can. Hydrogen's pull is a little bit weaker. So even though that we still say they share the electron, which one has the electron a little bit more often or a little bit closer? Chlorine does. So since chlorine has a negative electron a little bit more, we say that it's a little bit negatively charged because it can pull on the electron a little bit closer. And hydrogen, since it can't pull quite as tightly as the electron, sometimes it looks like it has kind of like a positive charge because it's kind of losing that electron a little bit. So, in a polar covalent bond, are the atoms shared? Yes, they are. Are they evenly shared or unevenly shared? Well, they're unevenly shared because chlorine is stronger, so to speak, than hydrogen. Okay? So we say that there's slight charges on the atoms now because it's kind of unequally shared. And then the last type of bond is the ionic bond, which you guys are familiar with. And that is when one atom is so completely stronger than the other atom that it completely steals the electron away. So when chlorine completely steals the electron away, does sodium have that electron at all? No, it doesn't. This ionic bond is fully polar, meaning it's fully charged. So here's what I kind of wrote about it. That there's a complete transfer of one or more valence electrons. Both atoms are fully charged, forming one cation and one anion. And let's review again what type of metal forms the cation and what type of metal forms the anion. Well, let's think. Do metals like to gain or lose electrons? Here are your metals, and they normally like to lose their electrons, right? So metals are normally going to be positively charged. Anything that's positively charged is called a cation. The metal that's losing the electron is called the cation, and then the non-metal that's gaining the electron is called the anion. What this really looks like, if I was to draw it out for you, is that what this is really like a spectrum. Remember how we talked about the electromagnetic spectrum and how there's like different forms of light? Well, there's also different forms of bonding, okay? The more uneven that the atoms are in their strength, the more ionic it is. The more evenly their strength is paired, the more evenly they share their electrons, then the more non-polar they are. Okay? So ionic is very polar. It forms ions where there's a metal and a nonmetal. Anything that has two different nonmetals like carbon and oxygen or nitrogen and oxygen, then they're covalent because they're two nonmetals, but they're polar because they're slightly different strengths of nonmetals, so they kind of pull on the electrons with different strengths, which means that the atoms get slightly charged. And then the last kind is if you have two identical metals, like two hydrogens or two chlorines, then they're the same strength, so they can pull on the electron the exact same amount, so we call them pure covalent or nonpolar, meaning that there is no charge to any of the atoms. Now we've talked about something called electronegativity, right? Electronegativity is how much an atom wants to steal electrons. Down here is a chart for electronegativity. It shows you the electronegativity numbers of all the elements. Okay, what I want you to do is to look at this chart. Whenever you have calcium and chlorine bonded together, it forms something called CaCl2. Okay, that's the formula for calcium chloride. What I want you to do is figure out the type of bond between calcium chloride. Well, we have to figure out the difference between the electronegativity. Basically, we want to see how strong is calcium compared to how strong chlorine is. Well, let's look at the electronegativity value for calcium. Calcium has an electronegativity value of 1.00. That's how strongly it tries to pull on electrons. Now let's look at chlorine. Well, chlorine's in group 17, so we can assume it has a really high electronegativity value, and it does. 3.16 is its electronegativity value. So we want to find the difference between 1 and 3.16. Okay? So I do, in my calculator, I do 3.16 minus 1, and so my difference is 2.16. So I'll give you a relative value here. Anytime you have a difference in between 1.7 and 3.3, that means you're going to have an ionic difference. Okay, so we know that 2.16 is in between 1.7 and 3.3, so we know it's an ionic bond. So I write down here ionic bond. And then I'm going to have you write down which atom you think is more electronegative. Now let's do the next one. Phosphorus and oxygen form a compound called PO2. What's the difference between electronegativity? Well, we know phosphorus has an electronegativity of 2.19. Oxygen has electronegativity of 3.44. So when I put that into the calculator, I do 3.44 minus 2.19. And so my difference is 1.25. Whenever you get a difference that's between 0.3 and 1.7, we say that they're sharing electrons. It's a covalent bond, but they're not sharing it equally. So we say it's polar covalent. And you could probably guess what this last one's going to be. It's two iodines together. So one iodine has an electronegativity value of 2.66. And obviously, if you had a second atom of iodine, it would be the same electronegativity difference. And if I subtracted them, my electronegativity difference would be 0. That means there's no difference between their strength. They're equally as strong. So, if I go over here and I look, anything between 0 and 0.3, we say they're basically the same strength, so it's a nonpolar covalent bond. So here I'm going to write nonpolar Here's some food for thought. Try to think of relationships that resemble an ionic, a polar covalent, and a nonpolar covalent bond. So like a nonpolar covalent bond would be a relationship where you're both like equally in charge. That would be like you and your best friend, right? You're both on the same page. You both have the same strength. You both like your electrons equally, right? And like a nonpolar covalent bond would be something where you're kind of like equals, but one of you kind of has the upper hand on the other person, kind of like you and your little brother or you and your little sister. You're kind of a little bit stronger than them, so you can kind of steal their electrons more, but you basically have to share the same room, which really sucks when you're 13. An ionic bond could be like something where there's a big difference in strength, like you and your dad or your mom, right? Unless your mom's really tiny, in which case it'd probably be a polar covalent bond.